Humbard here. For this video, we're going to talk about the reading guide for Chapter 3. With this video, the first definition is acceleration, which is the change in velocity over some time. It's not specific. It's not a specific amount of time, it's just some random amount of time. The average acceleration is where it's a time interval. So it's over some interval of time that's specific. The instantaneous acceleration is, you can think of that as acceleration at one instant of time. Acceleration at instant in time. Constant acceleration is when it's constantly accelerating. It's just always there, so it doesn't stop. Always accelerating, or always there. Equals constant. Just some value. So free fall is when you are falling through the air without a chute, with just gravity affecting you, or the acceleration due to gravity pulling down on you towards the earth. Technically the force pulling down on you, but you get the idea. Falling without chute. All right. The variable g is the acceleration due to gravity. So a equals g, and that is 9.81 usually. It's different in different parts of the earth, but in general it's 9.81 meters over seconds squared, the units for acceleration. So our units for acceleration are going to be meters over seconds squared. Usually has a direction, which I'll note that because it's a vector. Initial velocity is just meters over seconds. Final velocity is meters over seconds as well. Time is in seconds. In physics, anyway. And velocity, of course, has direction as well. So I'll do that for both of them. So if we want the equation to determine the acceleration of an object, it's just a equals change in velocity over change in time. So if the speed is constant, or velocity is constant, then that means that the change in velocity equals 0, as v is our speed and it's minus some change in v, which is the same, so it's going to be 0. So a equals 0. So it is possible for acceleration to be negative because you can have negative velocity. For instance, you could, and that implies stopping. So let's do an example real quick. We'll say a is initially accelerating at 5 meters per second, and then it stops, so that goes to 0, our final velocity is 0, over some time frame, say it happens in 5 seconds. So our value, -1 meters over seconds squared. And the negative sign implies we're slowing down. All right, the velocity versus time graph of a constant acceleration is basically a straight line. So we have a v and t graph, but it's a straight line with a slope. It's going to have to look something like this. It can either be upward or downward because we have some change in velocity, some v initial and v final over some interval from 0 to some time. And rise over run is the slope. So m is for a velocity versus time graph, velocity for this graph. All right, for this question, the answer will be -5. The reason for that is we can actually break this problem up into two segments. We know when we get to the very top, for 16, the highest point, the velocity is going to be 0 at the highest point. So from here, and we're going to say that the acceleration due to gravity here will approximate as 10. We could leave it as 9.81. It would round out, but we'll just leave it as 10 to make the calculation simple, because I don't want to use a calculator right now. So we'll say that's 10 instead of 9.81. And now we can use this equation. V final equals V initial plus A t, just solving the acceleration equation for V final. And from here, erase that, we can plug in all our values to find the time. So V final is going to be 0 because it goes to the top, so we want the one halfway up. V initial is 5. We know A is 10, but since it points downward, we'll say it's a -10. And from here we can find our time as -5 equals -10. So time equals negatives drop. So 5 divided by 10 is 1/2 seconds. And then we know the full period will be 1/2 plus a half, because you just add it to get the full one, because this is the half time. So that's total time total equals 1 second. And from here, we can use that same equation and plug in what we have to get our V final. So V final for 15 equals V initial, which is 5, plus -10 times 1. And that's going to give us -5 meters over seconds. And if you chose to use 9.81, you get a value really, really close to that. All right, for 17. For this problem, there's actually two cases where you have different answers. In the real world, with gravity and air affecting things, the heaviest ball will hit the ground first, as it will have less air resistance, because it will slice through the air a little easier. because air resistance is dependent on mass. But in a vacuum, when you remove air, they all will hit the ground at the same time. So in vacuum, like in space, there's actually a video of a bowling ball and a feather dropping at the same time, where scientists remove air from the chamber, make it a vacuum, and they do drop at the same time. I'll try to find that sometime. So 18, equation for average acceleration, A equals change in velocity over change in time. Position time equation for constant acceleration. This one, we're going to use the fact that x final equals x initial plus v initial times time plus 1/2 a times the time squared. The velocity position equation for constant acceleration is vf squared equals vi squared plus 2a delta x. And if we have a race car that's rounding the corner at constant speed, the velocity is not constant because it is constantly changing direction, which changes the velocity value. So changes direction. So no.